Good morning to those who are here. Today is Wednesday, October 1st. Those who are watching this recording, good whatever time you are in, whether it's in the afternoon or the evening or the morning, the day after, doesn't matter. So this session is going to be recorded and it's dedicated specifically to the projects, okay? From the get-go. You don't have to do all projects. As a matter of fact, you shouldn't do all projects. You can do them, but only one of them need to be submitted for grading. Please don't confuse me and submit more than one, because then I will grade the first one that I encounter. So let's say, for example, I started with the Lunar Observation Project, and I find your name in there, and you get a grade in it. So you get that grade. Then I move on to the Lunar Photography Project to grade it. And I see your name in there, but I know that I have graded, so I'm going to skip that. And it could be probably the project you intended to be graded. Please don't do that. Please, if you submit one and you realize that that one is not the one that you really wanted to do, please remove it and put the other one in, or put the other one instead of it, so that I don't have to grade your that assignment you don't want me to. Or communicate. Send me a message saying, I submitted the photography project, but I really like the other one better, so I'm going to ask that to be graded for that. Hopefully, while I'm grading, I'll put a note on it so that when I'm grading, I will see the notes and then I will skip it and move on to the other one. Hopefully, this is clear. I'm going to send several messages to this effect, stating the fact that really only one project need to be submitted for grading. Okay? Do both projects if you want to. So let me show you a window first. Let me share the screen to show you that the projects actually are more than one, more than two actually. There was in the past a third project for this reason, and few other reasons I skipped the other third project. So let me go and share this application. So what you're looking at is one of the sections of Astronomy 120. So let me move this window out of the way. So what you're looking at is the projects that we have them assigned. This one, the retrograde motion of Mars, for some of you who are sitting in my astronomy labs, the title sounds familiar because there was a lab actually under this title. It's not the same. Okay? This project entails the actual steps that Mr. Kepler himself took to map the path of Mars. Okay, that project really needs a lot of supervision. And in the past, when I assigned it, I found myself basically guide. It's far more different than the lab, so that you know. Okay, for those who have the lab manual, I know a lot of you are not here right now. You're watching this recording, so you might see the title and you might think it's the same. It's not. Okay, but the idea is the same. We're supposed to find the path of Mars, not only that, but also deduce the eccentricity or the eccentricity of the planet Mars. So I removed that because of the difficulties that it's in it, and uh, and because honestly, there is another reason in that I really want you to go out and do actual observations. So that's why these two projects were kept in. If you notice, both of them are due on the same date. One of them is already has been posted for some of you. The others will be posted in the next week or so, so that you do one of them. Okay. The Lunar Photography Project, which was still not available for this class, it's going to be available. No, it's still not available for this class. So, but it's due on the same date. Okay, on November 15th. This requires only one observation. This requires only one time. You decide, you know what? The night is clear. I'm going to go in detail about this was the night clear, so I'm going to go out and look for the moon. Granted, the moon should be in a kind of a gibbous phase, preferably like last night or tonight. Okay, That's a preferred way of going and looking for the moon because and you will go in detail about that project. You will see you're supposed to identify as many features as possible on the moon. If the moon is new, there is no way you can see anything. So you can't, it doesn't work with the moon that is new. If the moon is a crescent, whether waxing crescent or a waning crescent, you don't really have a lot of features also. It starts to become interesting, honestly, when the moon is in a gibbous phase or more. Even if it's a full moon, that's fine. Okay? So that's why that requires some planning on your behalf. Okay? And I'm going to talk about it. The other project is the Lunar Observation Project. This requires 4 nights. Okay? Not too long observations, probably at most half an hour, maybe 15, 20 minutes observations each night. You document what you have seen and then you move on. Okay. So 4 nights for a whole month, basically, every once a week, basically, to track the different phases of the moon. So those are different projects. One of them involves you going for an extended period of time to take an image, to take with a camera or a phone or something, an image of the moon, and then document what you have seen on the surface of the moon. And then the other one is just to note its relative position in the sky and the phase that it's in for a whole month. Okay. It's not as long as the first one in terms of a single observation, but it's an extended observation. So at the end, they amount to the same time, basically. Okay, so when you average them out. Okay, so let me click on this one since this one is already uh, has been already announced. Okay, so the lunar photography. So let me click on the lunar observation on a new tab. And I want those who are present, at least one of you guys, to tell me that you can see the lunar observation projects. Yes? Anyone of those who are attendees?
No.
You don't see the lunar observation project
Like see
attached
it in Canvas or see it on the Zoom?
on the Zoom.
Oh, yeah, I see it.
Okay, very good. Thank you very much. Okay. So, because I want to make sure I'm sharing the right link in here. So when you go to the project, this is how it looks like. There's a bunch of instructions in here, okay? And some information, background information. And the fact that the moon takes on average 29 and a half days. So that's how long you're going to be looking at. Either 29 days or 30 days, okay? So you're going to track the moon over 4 weeks. Not every night, once a week, basically, okay? And to give you some information, very interesting in here is you have two files that you can click on. One of them is a PDF file, and one of them is a Microsoft Word file. Either one is fine. Okay. If you're familiar and used to Microsoft and how to use with it, go ahead and download this file. Click on here and download it and start using it. Okay. In other words, start answering the questions right on the Word file, the Microsoft Word file. That's fine. However, you can also do the same thing on the PDF file. The advantage of the PDF file, it retains its format. It retains the page numbering, it doesn't move page to next page, and it keeps everything in a clean and nice, concise place. If you don't want to do that, that's fine. If you are not familiar with Microsoft Word or don't want to bother with it, even if you're not familiar with the PDF and how to you fill out the form, and you don't want to bother learning it, that's fine. And you'd rather do it manually on a piece of paper and a pencil, that's fine too. Okay. At the end of the day, you need to answer all the items that are listed in these files, though, in these instructions. Okay. So don't skip the fact that you're going to do it on your own. Don't skip, for example, this section. Okay. The date and the time when you did your actual observations, okay? The shape of the moon on that day, how does it look to you? Looks all round, all lit. Here, What I'm looking for is just common way of describing it. Here is a more accurate way of describing it in a sense. What phase is it? It's a crescent, for example, and it's a waxing crescent or waning crescent. It's a gibbous, a waxing gibbous or waning gibbous. It's a quarter. It's a first quarter or a third quarter. It's a full moon or it's a new moon. So all of these phases needs to be documented, and the position is not an exact position. So please don't go and open something fancy and try to describe the position using some altitude and azimuth because you're not required to do that. You're not required to report the right ascension and declination of the moon. That is not the intent of it. So you're going to look, for example, it's southeast, okay? Or southeast this way. I'm sorry, I'm in my room and I can't even tell. Southeast or southwest. And it's just above the horizon or right almost closer to the zenith or somewhere in between. So what I'm looking for in here, not numbers. I'm looking for a relative position of the moon, okay? So basically that you actually went out physically and did it. And part of the description also, when you look at the shape of the moon, you're going to tell me which side the lit part is. If the lit part is facing to the east again, facing to the east. If the lit part is facing to the west, you're going to tell me facing to the west, okay? Like, for example, if you go out tonight, you see it's a gibbous moon with the lit part facing the west, okay? Which means really it's a waxing gibbous. It's a gibbous that is increasing. So the full moon is coming in the next few days. So that's the point that you're trying to do. Had it been the other way around, then it's going to be a gibbous that is waning because it's shrinking gibbous. So that's basically what I'm looking for. So all of these questions are graded. As a matter of fact, there is a rubric in here how you're going to be graded. So you're going to make a full marks for question one. So what is question one? This is how you can do things with me, okay? You don't really have to read the instructions. You can come straight to the rubric because that's how you're going to be graded. And you can grade yourself, as a matter of fact. You shouldn't wait for me to grade you. So you look in here, it says question one, you will get 3 points if it's correct answer. You get no points if it's wrong answer. You could get partial credits for it though. So what is question one? Here is question one. Question one, which position A through E of the moon best corresponds with the moon phase shown in the upper corner? I don't see a picture here. I don't see nothing, but I bet it's in here in the PDF file or the Word file. So I'm gonna open this file. So I'm gonna download it first. Okay, open. Do you guys see it or not? Or should I close and reopen this window?
I see it.
Okay, very good. Thank you, Johnny. Anyway, if you worked with somebody, you're fine. This is actually a good project to work with some people. Don't work by yourself. If you have family members, you don't need to list them. What I'm after in here is classmates of yours, including from other sections. So if somebody is in the college, you can put their names in here because it gives me a chance to go and see their work and compare it to yours, okay? But obviously, if it's your brother or your sister or your boyfriend or girlfriend, then in this case, I'm not going to be able to check their work because they are not enrolled in the college. So you don't need to list anybody other than the students who are enrolled in the classes that we have. Even if it's a friend of yours who's in college, but attending, for example, I don't know, math classes or some other majors, but decided to go and work with you, that student is not going to be accessible to me. So this is a chance for me to see how your work compare. So if it's somebody else and you are sitting in astronomy 120 section 1, for example, and somebody else is sitting in astronomy 120 section 70, and you decided to work together, that's fine. You can work together. I can connect the two and see how your work is. This is your name. And this is what the question was we're referring to. Which position A through E of the moon best corresponds with the moon phase in the upper right corner? The sun is in this way. What you're looking for is the lit part, which way it's facing, okay? And how much is it? obviously this is a crescent, and I need to decide, is it a waning crescent or a waxing crescent, okay? So if this was the west, then which side is this one is facing? And I have to depict a position in here out of all of this, okay? Which one corresponds to the phase that we have in here, okay? Once you have that answered, once you decide which phase, you have to justify it in here. It's, for example, phase C, because so and so and so and so. Because it looks like it's less than 50% lit. Less half lit, you don't have to go 50%. It's less than half lit, and it's facing east. So if that's the correct answer, that's what I'm going to put in here, okay? And I have to describe it. So if I decide the C is the correct answer, obviously I'm not saying it's C is the correct answer, and I'm not saying it is. So it's you to make that call. And again, this is not an exam. So you can look up the references, and there is a discussion in here, and you can talk among yourself, and you can come approach me and say, how can we justify these things? So that's for you, it's a process of learning. That's part of the objective of this projects, for you to go and research and come up with hopefully a good answer. Okay. So now C is excluded. So I'm left with A, B, D, and E. So if I look in here, so C is here in part one. Then I have to say label this one A. And this is how it looks like had it been A. That's what the next question was asking. How does the moon would look like then had it been in position A? Because you said it's not A, so you said it's C. Then A would look like this, and you can draw it by hand and then click on it and upload it in here. Okay. Please don't take pictures. Don't go out and look for the moon. This is not the photography project. So if you do take pictures, I'm going to deduct points. I'm assuming that you didn't do the graphing with you. Because the purpose of this one is to do it. It says in here, sketch. Sketch is by hand. I mean, you can do it on a computer. If you're good with paint, you can try to use paint and upload it. Or you can do it by hand. Why do you have to just draw a circle and how the lit part, where does the lit part start and where does it end? And that's it. That's basically what we're looking for. And then put me the label. This is how A would look like. This is how B would look like. This is D how it looks like. This is E how it looks like. Because I decided the correct answer to question A is C, okay? And I have my reasons for it. Again, I am not saying the correct answer to question one is C. And I'm not saying it is not. So it's you to make that call, okay? So if you decide, for example, the correct answer is E, then E is excluded from the rest because E, and you have your reasons for it. Then you come in here and say, this is how A would look like. This is how B would look like. This is how C would look like. And this is how D would look like because E has been excluded. Okay, A, B, C, D are the remaining. So again, that's part of your project. So at this point, it's theoretical. There is no observation with it. You didn't go out and do this. Now, October 6th. October 6th is this coming Monday. We are today, October 1st. So this is starting soon. But you will see that October 6th is not really the date. It's October 5th when you need to go and do your planning. So you're going to receive a message from me to go out on a Sunday afternoon and spot the moon. So you take your notes and okay, I'm looking east, there is no moon. I'm looking south, there is no moon. I'm looking west. Oh, here is a moon. Oh, the time is so and so. So when comes the day of observation, it's October 6th, I know exactly roughly the time and the place where to find the moon because it doesn't change a lot from one night to the next night, but it does change. Okay, that's part of one of the labs for those sitting in Astronomy 125. Anyway, but I can hunt for it. I already planned my thing. But I look for it, for example, on the 5th to the east. I don't see no moon. I look for it to the west. I'm in south and I don't see no moon. I look for it to the west, anywhere in the above the horizon, there is no moon. Go in for an hour or 2 hours, come back, same thing. just before I go to sleep, same thing. Wake up in the morning, look for the moon, and here is the moon, for example, in the east, above the horizon, at 6:30 in the morning or 7:05 in the morning. I already have made my observation for the sixth. That is the sixth observation. So I know how it looks like. I know its rough position. It's south, east, just above the horizon, or a little bit midway between the horizon and the zenith, or actually sitting in the middle of the sky. Okay? And I sketch its shape, how it looks like, and so on and so forth. I have answered all of that observation. But let's say, for example, for the sake of argument, when in the morning I don't see it, nowhere. Come the sixth, the same reason, the same thing. I don't see it nowhere. The seventh in the morning, I don't see it nowhere. Then in this case, there is no moon. I can't see it. So I could infer what that phase should be when I don't see the moon. For those of you sitting in my Astronomy 125, you know exactly what that phase is. For those who are taking the lecture after reading Unit 8, you should know that that's new moon. Okay? And that unit has passed a long time ago. So you need to go back to that unit and make sure you understand the moon phases. Okay. Let's say, for example, the weatherman said the 6 is actually going to look horrible. There is too much cloud. So you can see it anyway, even if you go out anytime. The 7th also. In that case, I rely on my observation of the 5th. Because I already did observations on the 5th, although that was a planning observation. I go to the 5th, for example, and I don't see the moon because of the cloudy conditions. I go to the 6th and I don't see the moon because of the cloudy conditions. So there is a 7th that gives me the chance to look for it, and hopefully the conditions will improve. Now, if the 5th fails for me, the 6th fails for me, the 7th fails for me, for weather conditions, can we mute that, please? Okay, very good. Thank you. Anyway, so if all of these dates, the weather does not permit me to observe the moon, then in this case, I say in my notes in here, I did my observations, but the weather was not cooperating. And that happens in astronomy, by the way. For again, those who are sitting in the lab, you will encounter this situation. So this situation is not an impossibility. Are you guys still seeing my shared screen or not?
Yes.
Okay, very good, because I'm kind of anyway, so if it fails on your 3 dates because of weather, you just state the fact that, hey, the weather was, I mean, we're blessed here in Southern California, the fact that we don't have that problem. But I know those who are taking my online classes, they could be traveling or they could be somewhere else. And the weather doesn't cooperate with them. Some of them living actually in the mountains in here in San Bernardino, they could have the same problem, the problem with the weather. So the weather is actually part of the course. So it's part of the problem. So if the weather doesn't allow you to look at it, that's fine. So in here it gives you October 6th, but please understand that you really have to consider October 5th first, because of the fact that that's a planning visit, planning observation, and then the 6th is the actual observations. And if both of them fail for one reason or the other, then your 7th is the last date. You don't do the 8th. If it fails on 3 days, that's it. You lost that opportunity, that window. Okay. So again, what I said in here, you're gonna put the date and the exact time. Please be accurate with your time. How the moon looks like. Is it mainly lit, like a gibbous? Is it partially lit, like a crescent? Is it not there at all, because you couldn't see it? Is it all lit, like a full moon? Is it halfway lit, like a quarter moon? And which side the lit part is facing? The lit part is facing either west or east. Okay, so you're going to tell me basically in here. So I'm looking for words in here that don't necessarily be technical. Here is we need to be technical. Because the lit part is facing the west, for example, we know it's waxing if it's a crescent or a gibbous. So I'm going to say it's a waxing gibbous because so and so and so. And the moon was in the west, for example, midway or just above the horizon, midway in the east or just above the horizon, or way in the sky. high in the sky, or south, for example, way in the middle of the sky. So basically, those are the positions here in northern hemisphere that I'm going to consider. But name the phase. You don't need the numbers. Again, you're going to sketch what you have seen by hand, okay, and upload the picture in here, okay. You do the same thing around the 13th. You do the same thing around the 21st. You do the same thing around the 29th. And here the conclusion has to be something open. First of all, document how long all these phases took, basically from the beginning to the end. You know that on average, a synodic month is 29 and a half days. So did that match your expectations? Was there something wrong with it? And what did you learn from all of these things? Okay, so that's basically what I'm looking for in here. This is project one. Don't forget that you have a rubric. So please try to follow this rubric, okay? This is how you're going to be graded. Get 5 points, 5 points, 5 points, 5 points, total of 34, 6 points in here. So you get the 34 points altogether. And there are some details in here of what's missing or what's included. So please take care of it if you're going to do this project. So this project is one thing. Now, notice the following for, I have it open with a normal Microsoft, what is this, an Edge? So if I put my name in here, it's for some reason now it works. In the old days, it did not work. Okay? Now you can fill it with a Microsoft. So it's a fillable form. So I could insert, but let me see if I can upload an image. So here, I'm trying to upload this image, but I can't. But let me show you, if I open this one instead, so I'm going to save it somewhere. It's already in my Astronomy 120. So I'm going to go there and find the file and show you how you would open it differently. That works better, okay? Astronomy 120. So let me stop sharing that screen and share with you. Share. Where is the folder? Don't give me the folder. Share screen too, that's fine. But before I do that, let me minimize this window. I don't want to. And let me get the image. Okay, that's fine. Let me move it this way because I really don't want to share the pictures of people who are sitting in here. Anyway, so let me go back to the share. And let me share screen too, okay? So hopefully you guys are looking at the screen. You guys look at it? Yes?
Yes.
Okay, thank you. So basically what I have in here, I have the folder where everything else is in here, okay? One of them is the moon phases form. This is the one that you're supposed to be looking at. So I'm going to click on it. And it opened in Microsoft, I mean, not in my, uh, Adobe Reader. And Adobe Reader is better than any browser that you have in there because you can do the same thing. One of the things in here, if I try to submit this one or save this file without including my name, it's going to throw an error. So because you saw this is surrounded by a red indicating that this is a required field. Partners are not required. So if I go in here, I see where I can answer the questions. But more importantly, honestly, when you do it from Adobe Reader, is all I have to do is click here and allow, enable JavaScript, whatever, for this document. So there is some security issues that sometimes they don't want you to, because that's where viruses start from. So once you do that and you trust this software, this application, because I think there is nothing wrong with it. So I'm gonna pick up a picture and it doesn't matter. Let's say, for example, this is my sketch. After I sketched it, I uploaded it to to my computer via taking an image or whoever method it is. So now I took that and I'm going to upload it. You see how it is, how easy it is compared to the other one. So all you have to do is double click on in here. I sketch the image and I already uploaded it to the computer. After I allow the security to allow to do this because it doesn't want any script to run by default to probably upload viruses or stuff from your computer without your permission. But you know that you have a file in here that is saved, okay? And that is the sketch that you draw and uploaded. So it's an image. As long as it's an image, it's fine. And say, okay, and now the image has been uploaded. So that's why there is in the instructions, it tells you if you don't have Adobe Reader to go and download Adobe Reader, it's a freebie. It's a free software. If not, just go to the library. You should find a computers available and then work off of the library. But if you do that, please don't forget to log out of your Canvas if you're working off of Canvas, okay? Because sometimes people forget their login session. And I know that computers of the library, at the end of the day, they clean up everything and they delete things. But the person coming after you, they might decide, you know what? I don't like Astronomy 120 anyway. So upload stuff that is not what you really intended to do. So you don't want to leave your session logged in. That's my point. Okay. So the point being in here, this is for the labels and it works the same thing for this thing. So for example, after I decide how the moon looks like on that date, and this is probably how it looks like. So I'm going to upload the image and say, this is how it looks like. Obviously, this is not how it's going to look like. This is not the correct image. Anyway, so I have done all of these things for this project and I'm done with it. At the end, I save it and upload it back to where the project is asking me to upload my file, and I'm done with this project. Okay, make sense of those who are here? Sounds good.
Yes.
Okay, thank you.
Yes.
Obviously, if you guys run into,
Yes.
thank you. If you guys run into an issue, you need to reach out. Okay, as soon as possible. Please don't let it toward the end. The first part of this project is just observation and documenting it in your notes. Whether with hand scratches, you don't need to take pictures. Actually, you shouldn't take pictures while doing this. If you do that, you're defeating the purpose of this project, which is manual observation and documentation of what you see. Okay, that's it. Let me stop sharing and let me go back into where we were. We have two projects, remember? The second one is the lunar photography, and that one is slightly different than this one. So let me first of all find it. Is it this? No, that's actually. Let me find it first, and then look for then. Okay, so it's not this one. This is the lunar observation. This is the photography project. So let me go back to Zoom. Share. Stop sharing. I don't know what I'm sharing right now, honestly. Let me go back. Share. Not that. Share this one, the lunar photography. Okay, for those sitting in here, you guys should see something called Lunar Photography Project. Yes?
Yes.
Okay, very good. Thank you.
Yes, I see it.
It looks similar, but it's different. For this one, it's a single observation. You go and look for it one night, and that's it. But you have to dedicate a full night almost for it, okay? Because there are several things you're supposed to be doing in this project. Again, there is a PDF file, which I'm going to click on it and open it. It's similar to the other one. It's identical to the other one. So instead of saying save as and then locate it on my computer, work for it with PDF, which is better, and it gives me the option to save stuff off of it, I'm going to open it directly in the browser, and it's the same thing. Your name in here, okay? Answer the first question, answer the second question, and you move on. And again, there is a link in here where you're going to upload an actual picture of the moon. This is where you actually have to take a picture of the moon, whether your phone or with the camera, as long as you take a picture of the moon. If you do take a picture of the moon, and if it's a full moon or if it's a gibbous moon, lower the what you call it, the speed of the increase the speed of the computer, the phone or the camera, because you want to open the shutter and close it right away because there's too much light coming in. If the moon is some sort of a late phase or closer to midway, basically lit, whether it's a toward the first, whether it's a waxing gibbous or waning gibbous, then in this case, you probably need to slow down the shutter. In a sense, you want to give it time to collect as much speed as possible. Most phones nowadays are automatic, as long as you hold your hand steady, okay? And you don't have a lot of distractions in terms of lights around you. In other words, there is no light sitting right above you because it's gonna really obscure what you're looking at in the background. Then you should have a good image, okay? What I don't want to see is an image from somewhere else. You go to Google and say, okay, can you Google find me an image of the moon, how it looks like? And then you upload somebody else's picture. Because believe it or not, it's easy to trace those images back. It's not hard for me to run a quick scan on all of the projects and pick up those that were actually copied from somewhere else, okay? So you have to be aware of that. It has to be your own picture, even if it doesn't look too good. It has to be your own. Okay. The purpose is not for you. You're not expected to be a professional photographer. That is not the purpose. Okay. Purpose is you actually go and do it. I'm hoping that you actually go outside and do the actual photography. Again, this is straight from Unit 8. This is the beginning of the lunar month. Okay. The west is here. The lit part is facing the west. The sun just set. So this is day 2, day 4. Day 8 we have a quarter moon. The lit part is facing to the west. We have a gibbous, like for example, if you go out tonight, this is how it looks like. A gibbous where the lit part is facing the west. So we're still in the first half in this case. Now we have a full moon. The minute the sun sets, the moon rises and it's full. Okay? So this is day 15. On the next day, on the same day basically, so the moon starts in here and stays the entire night, and the sun is, of course, missing the entire night. By that sun, the sun starts to rise, the moon starts to set. So this is the same day. And then the lit part now, it's a gibbous in the west, but the lit part is facing the east in this case. So it's a waning gibbous that is shrinking in size. Now this phase is half lit, half not lit. Again, this is half lit and half not lit. The difference is this lit part is facing the west. Therefore, this is a first quarter and this is a third quarter because it's facing the east. Anytime the lit part is facing the east, we're in the second half of the lunar cycle. And in this case, um, uh, if it's gibbous, it's a waning gibbous. If it's a crescent, it's a waning gibbous. As opposed to here, where if it's a crescent, it's a waxing crescent. And if it's a gibbous, it's a waxing gibbous. So basically, this is what this stuff from Unit 8 is all about. Okay. Now here, full versus new moon. Based on the pictorial summary at that time of the day of the moon, at what time of day would the new moon arise? Okay, so you're going to look at the picture. If not, review the unit further, and you should be able to answer this question easily. Now, here is a part where you're going to actually go and do your observations. Please don't do it during daytime. It has to be at night, okay? When you did, this is the start time. Of course, it's going to be PM, the observation date, and the time. It has to be a date after when this project release, which is going to be a week or 2 at most for all of you guys. And before November 15th when the project is due. So you have to remember that. So what phase of the moon you observed? I'm hoping it's going to be a gibbous of some sort, whether it's a waxing gibbous or a waning gibbous, okay? So around day 11 or day 19 in the lunar cycle. Please don't do crescents. Crescents or actually new moon. That's going to be a horrible experience to do because you're not going to see any features, okay? And the non-lit, were you able to observe any features of the non-lit? Because sometimes you do, okay? when it's still bright out, bright little bit, the day is bright, the non-lit part is kind of a little bit darker than the background, and you should be able to see it. But sometimes you don't. So this depends on your time and when you went and look for it. Okay. Again, this is your picture that you take. Okay. This is your picture. Now, what you saw when you went out and look at it, you have to remember these are the main features of the moon. This is the biggest feature that you're going to see from the northern hemisphere, which is the Tycho crater. And this is an impact, and all of this are ejectors and the traces they made, and different places that you see. Now, if the moon is a gibbous, you should be able to see all of these features basically. Okay, you're going to name them, what you have seen, the features of the moon. Okay, position and comparison. Which approach was easier for identifying the position of the moon in the sky relative to the sun and position of this observation? Okay, so again, please follow the instructions and try to identify. This picture is not mine, by the way. It's coming from the from Wikipedia. Okay, and adjust yourself in your observations. Again, this is a one-night observation. This is not like the first project, which is a 4 nights. Some of you, what happened in the past, they missed the first observation for one reason or the other. They have some emergencies, and they missed the second one. So then the lunar observation becomes mute. They continue doing their observations for their own benefit, but then in this case, in terms of a project to get credit for it, they switch back to this one. They switch back to the lunar photography project. Similar to the lunar observation project, there is a rubric in here, and each rubric has questions. The points are not the exact same number of points, but at the end, you will get 100% if you answer all of these things, or 100% on the other one. From the beginning and until now, it's still true. You don't have to do both parts. Okay. Now, on a contingency basis, if these things fail for one reason or the other, you might have the option to do the third project, but I really don't recommend it. That's actually needs more of a supervision than this projects. These projects are kind of uh, on your own. I mean, they're not hard to do. So these two projects, they're kind of they don't require, let me stop sharing. They don't require a lot of, kind of you have to do this, and then this. And you don't need a lot of protractors because the other one requires a protractor and requires a ruler, and it has to be meticulous. It's a lengthy. I mean, it's not lengthy in terms of observations, like for example, lunar observations, but it needs focus. For those who take my lab, you know how labs sometimes they can be very, very detailed. This one is a little bit actually more involved than those. Because again, you're supposed to be working on it on your own at your own time. So there is not like that lab environment where you're constrained by time and place and space and all of that. But it's an alternative for some of you who might want to do that. So I might open it for on a contingency basis. For example, somebody comes with an emergency and says, you know what, I can do the lunar photography project. I can do the lunar observation project, but let me do the retrograde motion of Mars, unlike the one that is on the lab, so that you know. Then I'll open it for them, and they will be able to do it. Okay, they will be able to do it. I'll try to give them some guidance, but there is only so much I can do with that. Okay? Remember, projects are critical for your lab, for your grade overall. I'm sorry, for your grade, because it's a 10% part of your grade. Unless you're working toward the B, you really should do this project. Okay, unless you know what, I can live with a B, I'm happy with it, then I'm gonna get a B and I'm done with this class. Then in that case, the project is optional for you. I don't recommend that though. Because if for some reason the B doesn't show up in that case through the normal work, then hopefully the project will bring it up to B. Okay, instead of getting a C, you get a B. So First of all, don't do that. I mean, don't plan on getting a specific grade other than an A. You're planning to get an A in this class, not anything less than that, okay? So that's my recommendation for you guys. Hopefully you guys will do that. I'm available. You will be receiving messages from me reminding you of the planning observations and also on the actual observations for the lunar observations. And then also 1 or 2 reminders about the lunar photography if you opt for that instead. And hopefully you will follow those observations. Remember, if you miss your planning observation, it's fine. You can still do the actual observation. If on Sunday, for example, you didn't have time, you were tired from whatever you went to on that trip on that day, you came back and you remember, oh man, I'm supposed to do my planning observation. And you didn't do it. That's fine. The actual observation is actually on the 6th. Okay. And if on the 6th you don't see it, then indefinitely in this case, the 7th, and that's the extent with which you can do. Okay. Sounds good?
Yes, I have a question.
Yes.
Okay, so for the photography lunar observation, you're saying that it's better to do the observation after the 11th or on the 19th?
Yeah. I don't mean October or I don't mean November so that you understand. The
Hmm.
11th of the lunar cycle.
Okay.
Okay.
So
Not,
end of the lunar cycle, right?
yes. Remember the
Okay.
lunar the cycle starts from when the moon is new.
Mm-hmm.
It goes all the way to 29 or 30 days. On average, is 29 and a half days. So that is the cycle I'm talking about.
Oh,
So
okay. Thank you. I just had to clarify it because I was
oh,
kind of
very good.
confused.
I'm glad that you asked that question because probably some other people also are thinking the 11th of October or the 9th. I'm glad that you did ask a question. That's why I really want people to be attending because sometimes I assume that it's clear, but it's not. Okay.
Mm-hmm. Thank
So,
you.
anyone else?
So exactly what date you said we can start observing in the photography project?
In the photography project, you have the option to start whenever you want to. So if I go tonight, for example, and do the observations, the moon is a gibbous. Okay. But the unfortunate thing is tonight you don't have the project open for you.
No,
So
that's what I mean.
roughly,
When is it going to
roughly
open?
in about 2 weeks from today.
Oh, okay, okay, okay.
Okay.
So
Remember,
as soon as the project opens, then we can start observing.
yeah.
Doesn't matter
So
what
yes,
date.
because you
Okay,
don't have the instructions. So if I go
okay, got it.
tonight, it's gonna be a gibbous that is waxing. In 2 weeks from today, roughly, or less than two, it's a week from today. So it's gonna be into a phase, a full phase, and then it's gonna be a gibbous again. So in about a week or 10 days at most, it should be a uh, should be able to do this project for the photography. Or wait another 2 weeks after when the whole cycle goes midway. Okay. So you have
Okay,
win 2 opportunities really to look at it. But during that opportunity, you have several days. So it's not like, for example, the lunar photography where you're contained by the day. Let's say, for example, today is supposed to be a gibbous. Okay. Well, tomorrow it's going to be a gibbous too. The day after is going to be a gibbous most likely, or full moon. The day after that is going to be a gibbous too. So I have several days actually to go out and find it. Okay. So unless it's a crescent, then I
okay,
have to really wait a little bit longer to get it into that phase. Then in that case, I have a lot of opportunity. But honestly, even if it's a quarter moon, whether it's a first quarter or third quarter, so let's say, for example, I ran out of time. Now November 15th is approaching. You have a lot of window all the way to November 15th, by the way, to do that photography. So yeah, we'll have a plenty of gibbous stages. But let's say, for example, for the sake of argument, today is the 12th, and I didn't do my photography. I didn't do my observation, and now I'm going to do photography. The moon is a crescent. And in this case, I'm running out of time. So don't be constrained and say, you know what, I lost all of my opportunities. Go out, do it while it's a crescent, your photography, and mention the fact that you missed it for one or the other reasons to get as many features as possible, because that's the only opportunity you have while it was a crescent. And this is the only 2 or 3 features I could see in the moon. So my point is, you guys need to go out and learn how to go and do your observations. The moon is the biggest. So we're blessed on Earth because we have a big moon. Okay? If we are on Venus, and I'm glad we're not, we don't have any moon, so we can do none of these projects. We will have really a lame sky. As a matter of fact, the sun wouldn't be able to see it if we are on Venus because of the thick atmosphere. So people who live on Venus, if there are people who can live on Venus, they will not have astronomy for their people. I mean, they will have hardly anything. So it's not just astronomy; they will not even have life. So we're blessed. I mean, my point: even if you are on Mars, and in this case you have a two tiny moons where you can't even, you have to really work very hard to see them. And if you do, they don't exhibit any of the features of our moon. So take advantage of it. Go out, enjoy it. That's the main thing. Hopefully with one of your family members or friends or something. And then do you document your stuff. And maybe later on you could go and purchase a cheap enough telescope and you start looking for far more features on the moon and other planets too. That's good. Thank you for that question. Anybody else has a question?
I have
No?
a question. Yeah, I do, DJ. Are
Yes.
the projects the same amount of points?
No, they're not, but they're the same percentage.
Okay, that makes sense.
Yeah, so let's say one of them is 32 and you score 31, so you're not going to get 100%, you're going to get 90 something percent. And the other one is 34 and you score 32. It's the same percentage basically. Okay? Yeah, so at the end you get the same grade one way or the other. So in other words, there is no advantage from point-wise to do one or the other. Okay?
That makes sense. Thank you.
Thank you. Anybody else? Okay, let me check the chat because I see something in the chat. Well, good luck. Yeah, there are some cheap telescopes out there that are actually very, very good option, and that's from Astronomers Without Borders. They sell them for around $250. They are 5-inch telescopes. I think I have one somewhere in here, but I think it's in the other room. And they're collapsibles, meaning you can collapse the telescope and you put it near the car and you can go out and look at things. And one of the advantage of it is already comes in basically adjusted and comes with two eyepieces already. So it's a 5-inch telescope, which you can do a lot with it. You can see Saturn, you can see Jupiter, and you can see the moon. And that's the most you can do with any telescope. Even with a 10-inch telescope, that's probably what the best you can do with anyway. So that's really a very, very good telescope, and it's not expensive, and it's with a non-profit organization called Astronomers Without Borders. So you can go and explore that option, and it comes everything with it too. It comes with it's Dobsonian, it comes with a stand, it comes with everything. So go for it. It's good.
Thank you for telling me that. You said Astronomers Without Borders?
Yeah, let me find the link for you.
Okay, thank you.
Okay, let me find the link for you. Borders. What? What is this link? This is strange link. Okay, let me find the correct link because sometimes the people mimic other people's telescopes. Okay, let me take me to the store, and then I'm going to show you what I'm talking about. Oh, it's sold out now. Let me show you anyway. So the price increased. 2 years ago, it used to be $200. Then they raised it $250 because it's popular. Now it's $299 and it's sold out. This is the telescope I'm talking. This thing is collapsible, meaning, okay, this thing comes down in here. You loosen the screws and it comes down, and you flip it upside down, and you can fit it in any car. I mean, you don't even have to put it in the trunk. You can put it in your back seat, okay? And of course, when you're doing the actual observations, You have to expand it. You have to pull it up. This is the eyepiece, and this is the viewfinder. What is the? Let me get this thing out of the way. This is the viewfinder, so you can find an object first and look at it. And this is the secondary mirror, which is aligned with the primary mirror, which is in the back and here. You don't need to adjust it or anything like that. It comes adjusted for you already. And this is the stand. This is a Dobsonian stand. So this is where you put it on. Make sure it's on a steady surface. But because it's a low telescope, you sometimes put it on a table or something like that. So if you do a backyard astronomy, this is actually very good for you. And if you want to go travel or go somewhere else, this is actually perfect for you. I have a 10-inch and I have this 5-inch. I like, honestly, the 5-inch better than the 10-inch because it's easy to move. Even in my backyard, it's very easy to move. The other one is actually a nightmare. And I have a wheels for it and everything. But because my backyard has only a small section that is you can wheel stuff on it, it's hard to move it to the places. This one you can put it anywhere, and you're not missing much in terms of stuff in the sky that you can see with. Okay, so this is the telescope that I was talking about. Unfortunately, I'm sorry, the price has changed again. Okay, now it's $300. So it's a good thing to have, and because it's so popular that now they even don't have it in stock. Okay.
And these come assembled?
Yeah, it comes assembled. It comes in a package. All you have, oh, I'm sorry. You need to put the viewfinder. It's not hard to put. You see those screws in? This eyepiece, they come separate. You have to put them in because they have two of them. So depending on which what you're looking at, you either need the wide view one or the narrow view. So if you're looking for something, usually I don't like the narrow. I like the wide view because it gives me opportunity to look at things. So if I'm looking for Jupiter, for example, and it's smooth, the wide view is better because it gives me all of the moons of Jupiter next to the moon, Jupiter itself, and I can see Jupiter, okay, or the rings of Saturn or something, okay. So that's actually so this one you have to put it in. It comes with covers and all, and this one also has a cover that comes with it. So you need to remove the cover from the top because it protects the primary mirror from dust and collecting dust and other things. And this back side in here comes pre-adjusted. You don't need to loosen the screws. Or if you loosen them, you're risking the problem of having to readjust it yourself. It's a process called collimation, and you need a tool to help you do that. So you will need a collimator where you place it instead of the viewfinder, and you will have to look for the light lining itself from the secondary mirror all the way to the primary mirror, which is behind in here, okay? Once you're not using it, you collapse the telescope on itself and you put the cover and you put it standing still on a resting, and that's it. Okay. So that's how that telescope works. So it's actually a cheap one. I mean, compared to other telescopes, it's not bad for the price of what you get off of it. Okay. You get a lot of things. And it's amateur astronomy, so you're not wasting a lot of money just for doing something you like to do. Sounds good? Should I give you the link in here? Let me copy the link so that you have it in the chat. Yeah, it's a reflector telescope, okay? It's a Newtonian telescope. It's not a refractor, okay? Because you have the light comes in and reflects off of the primary mirror to the secondary mirror, and the secondary mirror reflects the light to your eye. So the primary light comes in and hits the mirror in the back, and then it focuses the light into your secondary mirror, and the secondary mirror they redirect it to your eye when you see it in here. Does this answer your question, Alfred? Yeah, okay, very good. Thank you. I didn't read the whole thing. Oh, you also have one. Okay, so you guys have the link in here if you decide one. Hopefully at some point it's going to be available. Okay, guys. If you don't have any further questions, I'm going to stop the recording. And I will see you guys in person for those who are sitting in my in-person classes, whether lab or lecture. And those who are online, we'll talk online. Sounds good?
Thank you. Have a good one.
Thanks. You too. Bye.
Thank you. Bye.
Thank you.
Bye.
Bye.
Thank you.
Okay, bye.